subscribe to our YouTube channel, Joy Learning TV.
Hello, my lovely viewers, watching us from your comfort of your homes. You are welcome to SHS1 on Joy Learning TV. This is your teacher, Kwame Amwatin, also known as Voice, taking you through SHS1 topic, Introduction to Integrated Science. Don't stand up. If your friends are not around, go and call them, because this is the first lesson you get when you go to SHS. Or if you're in SHS, this is the first lesson that your teacher will take you through. So I'm waiting for you to go and call all of them so that we have an exciting lesson today. You are going to be blown out of your mind about your perception about science. At the end of today's lesson, I want you to be able to mention some branches of science which are interrelated and relevant to the world of life. You'll be able to also apply what we call the scientific method to arrive at scientific solutions to everyday problems. The third part, which we'll take in another series, is how to follow basic safety precautions in the lab. Yes, when you come to our lab, you have to do what we say you should do. So the first part, which you just heard, is about science. Have you ever imagined why we have the word political science, social science, criminal science, or most words we add the word science to it? Yes, so start thinking. At your JHS, when you're coming to SS and they tell you to choose science, you get scared. But some of you are in some department in the school that we call social science or the home science. So you couldn't run away. You're still doing science. Then it should tell you that the word science is not for those doing physics, chemistry, and biology, as we usually say. Then keep thinking. Then why do we add the word science to politics, science to social, science to criminal, science to sports? Then we share something in common that is not only for the science people, as we usually call them, the science people. It's for everybody. So we define science as a continuous method of investigating and obtaining knowledge about nature through the word called scientific method. I'll take it again. We define science as a continuous method of always investigating and obtaining knowledge about nature through scientific method. Let's underline the word scientific method here. This particular word makes whatever we call science. The word scientific method makes whatever we call science. If you study anything and you subject it to a process called the scientific method, whatever outcome will be called science. So those bringing you the show to your house, maybe you want to study something about media and they subject it to scientific method, then whatever they are getting or arriving at is what we call science. So you can even call it media science if there's something like that, because they subjected the study of the media through scientific method. Let's say it doesn't rain and we want to find out why it's not raining. There are many suggestions. You can say maybe the gods of our land is holding the rain. Without doing any investigation, that's your answer. But if somebody should subject why it's not raining through the scientific method, then whatever fact they come up with at the end of the investigation will be called science. So it doesn't care if it's the physics, chemistry, biology. It is just any subject that has been subjected to scientific method. Remember, we'll go to scientific method in this lesson. So the last time, science can be defined as a continuous method of investigating and obtaining knowledge about nature through the scientific method. The science that I just described, if it's about nature, if we narrow it to nature, which is called the natural sciences, then we can have two types of this science. Again, when I started, I said science is a general term for anybody who subjects a study to scientific method, be it media, criminal, whatever. But if you narrow it down that you subject the study of nature through the scientific method, then we call it natural science. This then can be classified into two types. The first type is called the pure or natural science or basic research. The second one is called applied or technology. Applied science or technology. Why do we call the first one pure or natural? The aim of the pure or natural is that scientists just immerse themselves into research just to obtain knowledge. Just knowledge. Nothing more. The next group, called applied science or technology, are those who will use knowledge gained by the first group, that's the pure science, who just did the research for just knowledge's sake. Then these people will take it, apply it to solve a problem in our life, and we call this applied science. Maybe you will come across Alexander Fleming on the way, but let me use his experiment as an example. He, by chance, discovered that fungi, specifically called penicillin, can secrete some chemicals, and that one can kill bacteria. He noted it, studied it, made his notes, put the notes somewhere, communicated with the scientists. We all got to know that it's true. But nobody thought of taking it, putting a capsule, call a medicine or a drug, put it in the drugstore so that you can walk and go and buy and use it. So the second group, who took Fleming's knowledge or research, was able to put the whole chemical that was secreted by the penicillin into a container and call it a drug that can be sold at the pharmacy shop. They are in the group called the applied science. So you can now guess that before we always get an applied science, then people had already worked on the natural science. Yes, the applied or technology group always takes something from the pure science. Below are some differences that make it a little bit clearer for you. Now, between the pure and applied science, we distinguish them by some benchmarks. The first benchmark is that the pure science people just conduct research just for knowledge, whilst the applied conduct or apply some of the knowledge gained from the pure science to solve problems. The next one is that the pure science group, they only focus on understanding how nature works. They will just only study what is happening, put into an experiment, write out their findings, communicate their findings to other scientists, and that is what they are interested in. But the applied people, they will wait when these people are finished, then they focus on using the raw knowledge the pure science group has obtained for us to solve problems in fields that are beneficial to man or other organisms. For example, pure science people will come out with what is in a particular food nutrient. But the applied people can put it together and tell bodybuilders that if you eat this kind of food, it will help you grow more muscles. So in that case, the pure people just came out with what is in the food. The applied people has put it together to benefit a group of people. Another thing is that the pure science usually do research for research sake, not to sell it actually for money. They are not into commercial reasons. They are not doing it so that they get plenty money or to sell it. No. But the applied people always take the knowledge, buy all the machines, all the technology they need to put the knowledge they gain from pure science into a process that can solve man's problem. So they need to sell it to get more money to continue such works. So we say that the applied people have a commercial aim. The pure people don't have a commercial aim. Then one difference again is that the pure science people's work always leads to discovery of things. Because the thing we don't know, they are the first to come out with something. Then it opens our eyes. Then the applied people will take it, turn it, tune it, and get something out of it. And we say they have invented something. So most times the inventions had almost come from the discoveries. Some discoveries usually are accidental, as we would come across some of them. Now that you know the difference between pure and applied, at SS, our aim is to focus you more on the pure science. What your friends do in the science classes are mostly the pure science they are learning at this stage. If they go to the university, they can learn the applied. The pure science that we studied, which was just getting knowledge about nature, that nature has been divided into 3 areas in the field of science. The first area is the area called biology. It is the field that studies life, living organisms, and how they grow from day one to they die, how they interact with the environment, everything about organisms, everything about including you watching me in the house. Your dog is part. How you react to the weather is part. The little tiny organisms that get you sick is part. They all forms biology. Another group of scientists also study what we call chemistry. Mostly is the study of matter. During the interscience too, you study some physical science, some organic and some inorganic aspects. Then, still in this topic, you also will study what we call physics. You've heard it before. It's the study of relationship between matter and energy. So some topics like atomic physics, electricity, magnetism, the thing that when you touch nails with, it will attract it, heat, light, mechanism, and sound. All these ones fall under physics. These 3 main branches that we described usually are under the pure science. We will also look at some applied science. So when you get to the university, you have a pretty idea the courses you want to do. One of them is astronomy. Remember, applied people always use knowledge from the pure science. So once you are doing applied, know that one of your leg is in the pure science. You can't just go straight to applied. So astronomy is the study of celestial bodies in the universe, such as planets, satellites, and stars. Another area that you are familiar with is agriculture. Even in your school or in some schools, they have a course called agriculture or agri class. These people, you may always say they are going to plant, they are going to take care of animals, they are going to do that. It's not a pure science because they've borrowed a lot of pure science and applying it into cultivation of crops, taking care of organisms, increasing yield. All these ones, they need to borrow the knowledge from the pure. That's why we put agriculture under applied. The meteorology, which is the study of atmospheric events related to weather. I know when you watch the news, they will tell you tomorrow it may rain or it will be sunny. Such people are the meteorologists. Studying the weather means that they need to have some knowledge of physics, maybe some mathematics, some chemistry, which are the pure, which they have now combined to use to study the weather. So meteorology falls under applied. Engineering, which is the study of mechanisms, are also applied because they will apply the physics, the mathematics, some chemistry, and even some biology in the engineering field. Geology. The next is geology, the study of earth composition, structure, and its origin. How the world came about, the nature of the world, what is in the world, the percentage of water, percentage of land, the amount of certain elements that we have. Those who study this thing, this topic is called geology. So you can also see that they also need some physics, some chemistry, some mathematics. So you see, applied people always are taking something from we, the pure scientists. Another is biochemistry. So do two words, biology and chemistry. So we say it's the study of biology and chemistry in a unit within an organism. Yes, as you are sitting down, there's biochemistry going on in you. So people take their time to study the biochemistry that goes on in you. If you drink water, how does it work? If you take certain drugs, how does it work in your body? Those who study the biology and chemistry of things in a unit in an organism is termed biochemistry. Then the modern current area of science we call biotechnology. Remember, the word technology again is here. We said technology is applied, so it's here. But this one, we are applying technology of biology or in biology. So we define it as the development and application of scientific techniques of biology, that's solely biology, to the process that improve man's life. Let's say there are waste, your fecal matter you don't need, and we're able to generate gas from it. It's a biotechnology. You have waste that you want to throw away in your house, and you put in a container. Study how aerobic or anaerobic organisms can work on it, produce some gas, and you get gas from it. That is, you're applying a biology knowledge or a technology in the biology field to solve problem, and we call that one biotechnology. Another common area everybody has come across, you take a drug when you are sick. Those who study manufacturing or study the development, the chemical equation, how to put it together, how to manufacture the drug that you go to the drugstore or the pharmacy shop to buy, fall under pharmacy. So we say pharmacy is the manufacturing of drugs. Now you know a lot. You know applied and you know pure science. At this level at your SHS, the topic or the subject is called integrated science. Have you wondered why we've changed from the old word called core science to integrated? Yes, formerly it was called core science. Now we call it integrated. That means different parts has been put together for a reason. So we define integrated science as the study of various parts of science in a whole, such that none of the fields stand out on its own or stands as an independent subject. By the time you finish your 3-year course at the SHS level, the science that you are learning is termed integrated because you learn something from physics, something from chemistry, something from biology. There will be some mathematics there, there's some agric there, and we put all this together so that you get a good picture about science. So that when you get into issues, you know which one to apply. You just can't say, I'm studying physics, I won't study anything chemistry or biology, I don't like them. You can't do that. So that even a physics student have some knowledge in chemistry, some maths, some biology. The biology people also have knowledge in every field. Same, the chemistry people have some knowledge scattered around from other fields that they are using. So once you put different fields together to use in the field of science, then we say you are studying an integrated science. Why are we so concerned in telling you to study this, even if you are not a science student? As I said, if your friend who is not a science student is not watching, call your friend to come and sit down, because this topic is for all SHS students, and this is your first lesson in class. Why do we have to let you study integrated science? Don't complain, don't murmur, don't frown your face, because it's going to help you. The reason is that it is going to help you manage our lives properly. Because by the time we finish this lesson, and we are promising you always stay with us, is that by the time I finish this the whole integrated science, you know something about diseases. You know how to make sure that your food that you are supposed to eat is supposed to be hygienic. You are supposed to know when you take a liquid that is acid or a base and you just don't know, you have to find a way to test it. So you see, it's going to help you manage your life. Ventilation, when you get to a place, how should you behave? Why should you wear a certain dress on a certain time of the day? So these are going to help you manage your life. Because science is going to broaden you, make you apply it. If you even are cooking at the kitchen and you put in too much salt, what do? You have to add more water, and we term that dilution. So now you know dilution, you will know how to manage your cooking. I guess you are laughing. So you see that it will help us manage our life. The next is that it helps us to communicate our findings or discoveries for easy understanding. When you do science, you just don't stand up and conclude on things. When you finish the scientific method, you will just not open your mouth and say things and I believe it's like that, I believe it's like that. We don't say that, we don't do that in science. Things has to be of fact, and fact has to pass through a process. So once we get the finding of something passing through the process, we need to tell other friends what we did, the outcome, so that they also can know about it and use it well. For the economists, those in politics, it helps us build a strong economy via education. Understand it. The machines we are using are science. The ICT you are learning, science. The paper you are writing on, the pen you are using, all this has to be manufactured. And once they manufacture these things, it makes the economy grow. So you can't develop the economy without scientists. We are an integral part of the economy. So I believe you have to clap for scientists. Now, another benefit is that scientists with such knowledge may serve better on policy development. For example, if the flooding going on, they want to re-engineer the city, they will need scientists to sit when they are drawing this plan. You just can't stand up and say, we don't need them, let the politicians do. No, you will need us. So scientists are almost on most board to help in policy development. Then their role is also to help provide better medical care, transportation, and communication. You can come up with a lot of these things. You can come up with some ideas that we didn't even bring here, which are importance of studying this science. When I said it's called integrated, we want to give an example of how some branches are interrelated. If you want to even be a soil scientist, just studying soil, there's ground that we work on. The sample called loamy soil, clay soil, or sandy soil. Those who are able to tell is loamy, sand, this, they have to study biology, chemistry, and physics before they could even study the soil and come out with something. Pharmacy, those who go to do pharmacy, we also will need to know chemistry, biology, or mathematics. Same with agriculture students. They would have to study physics, chemistry, biology, and mathematics. So when you come to the science, that's why you see that in SHS, those doing the elective science are all doing the 4 areas. We have tried to bring a little of that in the integrated, and we've even added agriculture to it, so that you learn different aspects as a whole. Let's look at one application. If a crop is infected, how do we go about concluding that this one is affected by mosaic disease, or by rust, or by potato blight, or what? That agriculture student or person studying the crops which has been affected has to know something about diseases. Even first, he has to know something about the plant life. That means he needs to know something about biology, because how organisms grow fall under biology. Then the pest or whatever is causing the plant to be infected, whether it's a pest or any pathogen, it's also under biology. So to be able to solve one problem, you need the person to know something about biology. Once you know the pest, you may decide to spray it. To spray it means that you need an insecticide. Which specific insecticide means that you should know something about chemistry. In addition, the machine that you put the chemical into spray, whether you need a big machine, a small machine, depending on the size, whatever, means that the person has to know some chemistry, some physics, so that he knows how machines work. The amount or calculations that you need, whether 1 liter, 2 liters, whatever, means that the person has to have some background in mathematics. So you can see that to be a scientist or to study science, you need different aspects. But don't let that scare you. Now that we've studied science, the branches of science, and how science are interrelated, if you study science, what will you gain? What will you get? The most important thing is the career aspect. Some become pharmacists. Some will become doctors or medical doctors, as we call them. Some will become nurses. Some will become petrochemical engineer or engineers. Some would manage our water. We call them water management scientists. Some will study the weather, as we said, because now you can't go out without holding an umbrella. And it will hurt you that when you carry an umbrella and it also doesn't rain, it becomes a load. So what do? You watch the news. You watch Joy News. And you find out that they will tell you what will happen the next day. In that case, who is helping you? The meteorologist. So those people who study that aspect of science also get a job or get into a career called meteorologist. Basically, you are living in a house. School too, you are living in a building. You just don't stand up and put cement together and build. It's the job of some people, and we call them building technologists. They will calculate everything and tell us the quantity we need. To whip up your appetite, we always want you to know that when you study science, there's a future. And some of our predecessors have paved the way. We just mentioned some names of some famous Ghanaian scientists. Because most time you will be reading books and you hear about whites, but we have our own to celebrate. The first on our list is Professor Alote, one great mathematician. I think he's late, he's dead. Another is Professor Yeboah Jan, an ecologist. famous Professor Frimpong Boateng, the cardiologist who works on the heart at Kolebu. Another is Professor Kwesi Andam, formerly of KNUST, a civil engineer. Another is Dr. Raphael Ametor. He dedicated his life and his time studying the disease that affects cocoa, so that we can fight that disease, so that Ghana can get a lot of cocoa. So you need to clap for such scientists. Another is Dr. Isaiah Blanson, an aeronautics, study space. Then Professor Avan Adai-Mensah, a well-known figure in the field of science. He was a chemist, or in the field of chemistry. So we have our own, there are a lot. There are a lot. Professor Ramade, who was mostly the quiz mistress of the National Science and Maths quiz. The current mistress too is a biochem. Is also one great scientist in our field we celebrate. So we have our own to celebrate. Now we move into another dimension called the scientific method. When I started, I said that science is added to most words. I hope you've not forgotten. Science is not for the people studying physics and chemistry. I said that any subject that has been subjected to scientific method, the outcome, the fact that we'll get is called science. So at this stage, we want to look at that thing called the scientific method. That if you also know and you apply it, whatever outcome, you can call it science. So the scientific method is defined as a logical and orderly procedure of investigation to obtain fact about nature or observed natural phenomena. You would say that then we are unfair because we use the word nature here and natural here. As we recap, we said that if you apply science to nature, then it's natural science. So because this topic is under science, we are only narrowing down to the natural area, not the politics or no. So again, scientific method is a logical and orderly procedure of investigation and obtaining facts or knowledge about nature or observed phenomena that go around us. So you would find out that then what the question you are asking me as a good science student, listening to me, is that what is this scientific method? As we said, it's an orderly procedure and it is logical. That means when we tell you, you yourself, if you are not a science student, I know you accept it, that is a logical procedure. And it's orderly. You don't jump it. You don't mix it up. Please. So let's look at that process. The first of the scientific method is that always you have to observe things and identify a problem with it. If you are in the cities, you can observe that raining season is flat. So you have observed something. So then you ask yourself, then there's a problem. Why does it flat? There are times when we have certain fruits like mango. All of a sudden we say the cholera disease would increase. Why? So if you are observant, the word is observant, perceiving things that are around you, and you're able to find out or identify a problem with it, then we've started the first process of scientific method. So if you live at a place that they don't cover your dustbins and you find that in certain time of the year the smell is too much or the odor is too much, then you have observed something. Then you come up with a problem. Why does this smell or the odor become offensive at a certain time of the year? You ask me why, isn't it? You said why. And why needs an answer. So you have to give me an answer. That answer you are giving me, because maybe nobody has done the experiment to come with a fact, The first answer you try to give me, a guess that you try to give me, is called an hypothesis. So let's write this as an educated guess. Or suggestion you give. So if you suggest something or you make an educated guess or explanation, whatever you give, we will not say you are right or you are wrong. If you are in the boarding house and the room is stuffy and you can smell something for a certain corner, and you said, every time we come back from class, this place is smelling. Such is an observation. Then you ask, why is it smelling? Then somebody says, oh, somebody's hiding a wet or a damp shoe or something there, or somebody didn't throw their refuse away. Whatever answer you are giving is an hypothesis. Then you have to move on to prove whether whatever answer you gave is true. So what do? You have to conduct an experiment. An experiment is a process designed, thought of, planned to arrive at an outcome of a fact that you've put forward. So you do an experimentation. Whatever experiment you do, you come out with some results. These results, you have to write them. You would have to put it on paper. What you are doing is saying, we say that in science we call it recording of results. So every experiment will have some results which you need to record. When you finish recording this experiment, you need to analyze the results and find out that the statement you made at the hypothesis stage, it's your explanation or analysis helping you to arrive at that or not. So then, whatever the outcome, whether it supports it or doesn't support it, whatever statement, for or does not, is a conclusion. So let's go over the 6 process. You observe and identify a problem. You define the problem. You give an hypothesis. Then you conduct an experiment. Whatever the experiment, there will be an outcome. You record it. That is called recording of results. Then the 6th stage is where you analyze and you conclude your results. Now let's go back and you find out that scientific method is used every day in our lives. Doctors use them. If you don't know, when you go to the hospital and you are sick, what does the doctor do? You first look at you. Sometimes some would open, some will put something under your armpit, a thermometer. What are they doing? They are observing you. Yes, the doctors are always applying scientific method. They are observing you. Then they will also be asking themselves, what could be the problem? So for them to conclude on what they think could be the problem, maybe you are infected by this, you are infected by that, then they have to conduct an experiment. So they'll take you to the lab. They will take your blood, they will take your stool or your urine. Then they'll run the experiment. When they run the experiment, the lab technologist would write something. They will record the number of whatever is in your blood, number of things they are seeing in your urine or your stool. What they are doing is that they are recording your results. And what do you think the doctor will do after that when they bring it? He will analyze the data or the results and then conclude and say it is A or B that's affecting you. And based on that, he can give you or prescribe a specific drug for you. So even the hospital that you go, there's scientific method. So you should be clapping for scientific method. I left this space for us to all work on this. If you have mice growing in your house and you want to know what can make the mice grow bigger or increase in growth, what do you think you have to do? So probably you would have to conduct an experiment. You have to study a food that can let them grow well. Let's call the food, let's say, vitamins. What then will you do? You would have to find two groups of mice, group A and maybe group B. You feed group A and you feed group B for about how many days? Let's say duration. 1 week. Let's do it 2 weeks. What will you observe? Whatever you observe, you record. If A with the vitamin increases in some weight more than their equal counterpart, that was a B, then we can say that we then analyze and do what? Conclude. If A increase in weight than B, then we will then conclude that it's because they ate the same food plus vitamin. And if B did not increase, then we say B, lack of vitamins does not let them increase in weight. But if it turns out the other way, that eating A group eating with vitamin did not come out with any increase, then we say that eating vitamins does not bring about any increase. You don't force conclusions to go your way in science. Rather, when it doesn't go the way the hypothesis was stated, you'd have to go over the entire process and bring another hypothesis and do another experiment. So what scientific method does for we in the field of science, which now you're a young scientist, is that it provides us with knowledge that we can verify. Because the mice experiment we just did, if it worked out to be true, you can also take my experiment, do it in your house, and conclude. Then you can even extend it to other organs like your dog, your cat, and say that if I feed my cats on these, they would grow because the evidence is there. Then it provides a logical procedure for gaining knowledge. Because I have said it, you have tested it, during the process, you will also add more to it. And the whole process of doing experiments, concluding, always help us know which one works, which one does not work. In that case, we say you've added knowledge. Some great scientists to work are worth of mentioning. The discovery of penicillin that I mentioned along the way, how we got penicillin killing bacteria and we put it together to make the drugs. Then another is Henry Becquerel, who came out with radioactivity. It's one discovery by chance. During his time, Becquerel's time, the idea of X-ray has started by another scientist. And Becquerel, who knew much about this, put uranium, he used to study something about photographic screens and stuff. But he put a whole material in an opaque cover. Then he put a uranium around it, put it in the sun, thinking that the sun energy will split because he had the knowledge of X-ray. He will split it so that the energy would pass through the opaque material and whatever is inside can be revealed. True to their work, it showed some evidence. But the next day, he had wanted to continue this experiment, but the day the weather was bad, no sunlight. So he decided to pack these things and put in a drawer. The next 2 days, he came back, took his whole setup to go back and do it. He saw that the photographic screen inside the opaque thing, there was something showing on it. So he was like, if this thing was in a box, a drawer, closed, no light, which we thought is the light that would let it emit the energy, and it's in a box and it could still pass through, then what is in the uranium that could let it pass through? And this brought radioactivity, ability of some element to split, and in the time of splitting, energy is given out. And this has enhanced our X-ray works. The other is Archimedes, which is the law of flotation. The story says he sat in his bath full of water, and some of the water overflew the banks of the tap. Then he concluded, so it is his weight that has displaced that. And there's a whole funny story that I'll let you go and search about. At home, I would like you to apply this scientific method we just did to treatment of your water. If there's a disease like malaria, I will allow you to apply it. So first, go and observe an environment that brings it. Find out how do they get it, and maybe find an experimental group. One group with a condition, another group without a condition. Subject them to certain exposure, record your result, and come back and let us see the outcome. So that's your assignment I've left there. Now, scientists, as we discovered or described the whole scientific method, if you do your work in your lab, you've gone to find out how malaria, as I said, just go and do it. You came out to say, oh, sir, we've seen how malaria is transmitted. We've seen that when we drink this untreated water, this is what we get. If you eat this kind of food, this is what we get. And you did it in your house. How will I know? How will I know? So what you are supposed to do as a scientist is that once you do an experiment, you write it out. So you write an experiment which will have a title of the experiment, the aim, why you are doing the experiment, the apparatus. The word apparatus means instrument. Or equipment that you used during the experiment. If you use a thermometer, you write it. If you use a conical flask, if you're using a bucket, use an iron, you use whatever in the process, they are part of the apparatus. Then you have to state how you conducted the experiment, we call the methodology, so that I also in my small lab can also conduct the same experiment as you did and can say what you did was true or maybe there was something missing. Then we can compare our results. Then you observe, whatever you observe during the experimentation, you write it down. Whatever you write down, mostly we say is the results. Whatever you observe, you record it, it's called the result. You analyze and discuss it all in writing. Then you conclude. So this 8th process is what we term as writing report on science experiment. what did I say? Writing a report on science experiment. So for a scientist, you have to love reading people's research, people's work. Take your time. Then you understand how they went through it, and you can then get the knowledge. All the plenty we've discussed today, which is under science, what do you think science has done for you, or the importance of science to you? So by the end of SHS3, by the end of applying science every day to whatever happens around you, you can find out that science has brought an increase in food production. Yes, the research scientists, the agric people who are applied science, the extension officers, the disease control, the genetics group, they are all working to make sure that we have pamper harvest, plenty food, good storage systems, and we are saying that then they have improved food production because they use science. So you have to thank us. Also, another one is improvement of water treatment. Now, all of us like bottled water, pure water, whatever water, is because more technology has helped them process these water. Now with X-rays, big machines, endoscopy, without doing operations without cutting your body, anything. Now this whole thing has improved medical care. So that you can be in the house and even have your medical through technology. It's all improving medical care. Also, better shelter. I believe you are watching me because of good communication gadgets that Joy TV is giving to you. The cameras, the phones, the laptops, whatever that they are using, it's a means of communication. So each day that science advances science in this field, we say that they are improving communication. Now you can talk to me on the phone, you can do Zoom, you can do a lot of things, making communication better. Then science are always designing new instruments for those of us who need it to use it for our work. So I believe for this time we spent together, your first experience in class, you've loved it. If you are not even a science student, you're a home econs, you are business, you are this, today I've changed your perception about science. I've told you that science is not for only the physics, chemistry people. It's for all of us, if only you subject it to what? So as we bring our lesson to an end, we'll summarize what we've studied, because we said science is a continuous process of investigation. The integrated aspect, don't ever cry about it when we come to class. So if you don't like giving chemistry, love it. I'll help you love it so much. Is that we study different aspects, different branches to make it holistic so that you get a complete picture of a concept. Then we divided science into pure and applied science. Then we also studied the scientific method as a process of investigation that had about 8 processes. Then we did the application of scientific method in our daily process. What we didn't write here is how to write a report. So before I leave you, for you to crack your brain a little bit, I want you to go and solve these questions. What is science? You didn't know how to chew it the way or give us the same answer exactly as we did. Find your own way of putting the answer together. Then define the scientific method and just state 4 steps. I didn't say write and explain, just state the 4 steps, some 4 steps of it. Then distinguish between pure and applied science. I believe we've made our first encounter in class easy. Just be ready for the next topic. It's going to be practical, it's going to be lovely. So till we meet again next time, this has been your teacher, Osei Kwame Amwatin, also known as Boys, introducing you to integrated science SHS1 topic on SHS Hour on Joy Learning. Don't run away quickly. Wait, we'll meet again next time. Bye-bye.
Subscribe to our YouTube channel, Joy Learning TV.